The next topic we're going to cover is similarity, and we're not going to jump right into similarity today. Today I'm going to give you some time to continue working on your map projects, just in case you're not done. They were supposed to be due today, but since I cannot be there, I will give you some time today to continue to work on them. For those of you that are done, you can start working on reviewing ratio and proportions. And the reason we're going to do that is because it ties very closely into solving any problem that has to do with similarity. So we'll go over that a little bit more on Thursday. So let me talk to you about ratios and proportions. So a ratio is just a comparison of two numbers. So 3 to 5 is a ratio. Or 3 to 5, written that way, also a ratio. Or the way you're all very familiar with seeing a ratio is like a fraction, 3 over 5. A proportion is two ratios set equal to each other. All right, so whenever you see a problem like this, that's a proportion. Now, a lot of people forget very easily how to solve a proportion. Probably what you're used to doing when you're solving for an equation is you either divide or multiply or whatever on each side to get x by itself. And that's sort of what you would do here too. So if you notice here, like the x is divided by 8. And the way you would get rid of that 8 is you multiply both sides by 8. Okay, then over on this side they would cancel out. Over here you would have 8 times 2 divided by 4. And 8 times 2 is 16. 16 divided by 4 is 4. So x equals 4. Now, the sort of quicker way to do it whenever you have a proportion is to do something called the fish method. So for example, let's say you had a problem that was something like n over 6 equals 5 over 8. Okay, now we can obviously multiply both sides by 6, but a quick way to do this is what's called the fish method. And the reason it's called the fish method is that you can draw a fish to show you what to do. So the way the fish method works is always start on the opposite side of the fraction as the variable, and then draw a diagonal, and then back around to the variable. The first two always get multiplied together and then divided by the third term. So this, to solve for n, I would do 6 times 5 divided by 8. 6 times 5 is 30. So n is equal to 30 divided by 8. Now I can put that in my calculator, or I can just reduce it down. 2 goes into both of those, so it's 15 over 4, and I can just leave it right like that. Okay? Now it's pretty easy when the three things that are there are all just plain numbers. Right? Like when you have, say, for example, 20 over 12 equals x over 5. We can cross multiply. 5 times 20 is 100, and then I got to do 100 divided by 12. So x equals 100 over 12. That doesn't go in evenly, but 4 goes into both of those. So that's 25 over 3, or 8 1/3. It really doesn't matter what form you put that in. 8.3 repeating, totally fine. The important thing is that you know that to solve these, you can just do the fish method, or you cross multiply. So that same problem looked at as though you're cross multiplying it. Okay, if I multiply that, I get 12x. If I multiply those together, I get 100. And then notice, to solve from there, I'm going to do both sides divided by 12. Those would cancel. So x would equal 100 over 12, which is where I was right up there. Okay, now the reason I sort of backed up there for a second and talked about cross multiplying is that sometimes You don't have just plain numbers there. Sometimes you have other expressions. So, for example, let's say that I had a problem like this. 14 over 10 equals 16 over 2x plus 9. Okay, now here it's a little harder because I don't just have an x, I have a whole expression. One way to get around this is to use what I've called the Jessica method. For a second, just pretend this said y. And to solve for y, I'm going to do 16 times 10 divided by 14. 16 times 10 is 160. And then I need to divide that by 14. So 160, let's see, 2 goes into both of those. So we get 80 over 7, which is 10, 11, and 3/7, something like that. Okay, so that would be one way to solve for y. And then what I can do to solve for x is say 2x plus 9 equals either 11 and 3/7 or 80/7, whichever I want to do. I'm going to say 11 and 3/7. Then to solve for x, I'm going to subtract 9 from both sides. So 2x is going to equal 2 and 3/7. And then I need to divide both sides by 2. So 2 and 3/7. Now it's going to be easier to think of this in terms of a improper fraction again. 14, 15, 16, 17, sevenths. And when I divide that by 2, I'm going to get 17 over 14. Okay, now that's a pretty ugly one, but that's one way to do it. Now, if I didn't want to use the Jessica method, and I jumped back here, I would have to cross multiply. So cross multiplying here is pretty easy. 10 times 16 is 160. But here when I cross multiply, notice I'm multiplying 14 by this whole thing here, which means I have to distribute in. 14 times 2x plus 9 is 28x plus 126, I believe. Okay, and then to solve from there, now I need to subtract 126 from both sides. So I'm going to get 34 equals 28x, and when I divide by 28, I'm going to get that, 28. And then notice that reduces down to 17 over 14 also. Okay, so those are a couple ways to do those things. Now, what you're going to work on today is a worksheet that's just ratio and proportion review. I will have also provided a key so that you can check your work as you go. I don't think it's going to take you the whole period, so if you get finished, find something else to work on that's non-disruptive. Be cooperative to your sub, and I will see you on Thursday. Thanks.